Alright, today we are beginning trig, and we're going to talk about angles and degree measurements, okay? Alright, now you guys have done most of this stuff and you've gone, oh, I've already learned this back in geometry, but we need to talk about it again because it's hugely important. Okay, so some things we need to go over, deal with the first three terms: vertex, initial side, and terminal side. Okay. Alright, so when we talk about the vertex is this bad boy back here. It's where the crux of the two rays meet. Okay, this would be the initial side. Alright, and we would talk about the angle starting here from now on and going to here. Okay, and so that leaves this as the terminal side. So that's pretty easy to understand. Alright, so we're just going to go over vocab in the beginning and just work from there. Okay, now if you superimpose this over a coordinate plane, okay, standard position is always going to be right on the x-axis here. So this is going to be standard position. Okay, now any angle you go from here, and standard is also going to be equal to the initial. Okay, any angle you go from here, let's make a different color. Let's go nice blue. Okay, any angle you go from here, you're always going to reference back to that. So if you use an angle here and you go in this direction, you talk about it like it's positive. Okay, so this is going to be a positive angle. Alright, if you go the other direction, okay, that is going to be negative. Okay, so you need to understand counterclockwise is going to be positive, clockwise is going to be negative. Okay, so that's pretty simple right there. Alright, now what we're going to do is measure in degrees, and in the book they say that the Babylonians came up with the degree measurements and everything, and degree measurements are great, and they actually just measure the space taken up by the angle, and they believe that what was it? Let me read it. The Babylonians based their numerical system on 60 rather than 10 as we do today. In an equilateral triangle, they assign the measure of each angle to be 60. Therefore, 1/60th of a measure of an angle of an equilateral triangle was equivalent to 1 unit or degree, and that actually explains the next one as to why we measure in degree, minutes, and seconds, and in 60th intervals and stuff. And actually, there's some interesting ideas explaining that we should switch to a decimal system, which is, you know, units of 12 instead of decimal. So it's really kind of cool. But anyways, that explains degrees and everything. So when you write degrees, let's say I had 39 degrees, please use this keyboard shortcut. It is Alt 248 to get degrees. Okay. Now if you need minutes, minutes will never go above 60. Okay, that is one hash mark right there, so it's like a foot. And then same thing with seconds, it will be measured with 2 hash marks, so a quotation type thing. Okay, this number in front, the degrees, will never go above 359. This will never go above 59, and this will never go above 59, because once you hit that 60, you do the carrying over and all that stuff. Okay, so we have this right here. Now here's the thing, how do we convert this to a decimal? Well, what we do is look at it part by part. Okay, so what we're going to do is, let me double check the method real fast. I always make this mistake when I'm converting. Okay, is I treat it as the addition of a couple of fractions. Okay, so 39 is going to be my whole number, and I'm going to add it with the first decimal, which is going to be 15 divided by 60. Okay, and yes, there are 60 minutes to a degree. Okay, and then what I'm going to do is I'm going to add 45 divided by 3,600. Okay, and why 3,600, you ask? Because there are 60 seconds in a minute and 60 minutes in a degree. So therefore there's 360 seconds in a degree, or 3,600. Okay, and once I get those decimals, I add them all up. So this should be 39 plus, do my calculator, 15 divided by 60. That should be 0.25. And then I go 45 divided by 3,600 plus 0.0125. Okay, and I should get 39.2625. Okay, and there's my version that I go to. Alright, so that's how you go from degrees and minutes and seconds to an actual decimal, okay, version of it. Now, if I wanted to go backwards, okay, you could break it apart like this. I believe the method is, okay, so let's say I wanted to do something, let's say 74.6723 degrees, okay, and Alt 248. So once again, Alt 248. Okay, so once again I do 74, and I'll have that as the degrees. Okay, now I'm going to do the actual minutes, and what I'm going to do is times this decimal, 0.6723. I'm going to times that by 60 minutes. Okay, and get that part, and that's going to be 70 degrees, and let me see, 0.6723 times 60, and that's going to be 40.338 minutes. Okay, now if you notice I still have a decimal, so what I'm going to do is I'm going to convert this to a I'm going to convert that to 0.338 times 60 seconds. Okay, I'm going to convert that to its own seconds version, and 0.338 times 60, so 74 degrees, 40 minutes, 20 seconds. Well, it would be actually 20.28 seconds. Okay, and it's okay to leave that last one at the decimal because it's not going to be the end of the world, and it actually gives an accurate position. Okay, so that's how you actually work with that one. Okay, now if you are talking about working with a coordinate plane and we go around once, okay, you have to imagine that that's going to be 360 degrees. Okay, now if you go around the other direction, it's going to be negative 360 degrees. Okay, so if we choose to go around in the other direction, boom, boom, okay, it's going to be negative 360 degrees. So when you're talking about rotations, you just have to think about how many you have and just multiply them by the rotations, the degrees, the 360. Okay, now coterminal was another definition from in here, and then we'll go to reference angle in a sec. But coterminal in the coordinate plane, they are angles that end in the same position. And I typed off the screen. There we go. Okay. So they're angles that end in the same position. So, for example, if I take this right here, oh, that's ugly. Let's make it look nice and neat. Okay, so if I had this angle right here, and let's say that this was 45 degrees, Alt 248. Okay, so that was 45 degrees. Now if I go around another 360 degrees from that position, okay, I would just find out that new angle to be 405 degrees. Okay, and or I could go the other direction and go 45 minus 360. So in other words, I could go the other direction and subtract 360 from it, and I would find it to be negative, I believe it's 315 degrees. So and as you can see, this is going to go on forever and ever. So this could continue to go on and just finding all kinds of angles that end in the same spot as 45 degrees. So that's coterminal right there. I could add or subtract 360 degrees to it. Okay, so that one's pretty simple. Alright, now if I wanted a reference angle, okay, that's something different. Reference angle is just the angle made with the x-axis. So if we were to just designate this to be the x-axis, it's the angle made with it. So in quadrant 1, okay, let's use a different color. Let's use green. In quadrant 1, the reference angle is just the angle. So if we call it alpha, and alpha is alt 224, that is going to be the reference angle. Okay, so that's just going to be the angle measurement right there. Pretty simple. Now if we go to the second quadrant, okay, which is this angle right here, okay, and let's say that that was alpha right there, alt 224, okay, let's say that that was the angle, then the reference angle is going to be equal to 180 minus alpha. Okay, so that's how you find the reference angle if you're dealing with something in the second quadrant. Now if we were dealing with something in the third quadrant, let me move that a little bit, there we go. Okay, so we go around right to here, I believe third quadrant, yep. And let's say that that was alpha, so 224. Okay, the reference angle, and I'm just going, that is going to be alpha minus 180. Okay, and if you go all the way around to the fourth quadrant, okay, and this works for going the other direction. You can also, well, no, this doesn't work for that direction. This just works for this direction. Okay, and let's say that this was alpha, your angle. Okay, then the reference angle, which is the angle made with the x-axis, that is going to be 360 minus alpha. Okay, so that one's pretty simple. Now this does show up later, in which you can find relationships between, and I'm going to just break the spoilers here. We're going to be talking about sine, cosine, and theta. No, sine, cosine, and tangent. Okay, and that's pretty much it for it. You could test an angle and find its coterminal angle. The reason being is when you do the actual trig, you do need to be able to do the reference angle. So when you're simplifying trig ratios, you do need to simplify by using the reference angles as help. So if I gave you 315 degrees as my reference angle, 248, then the reference angle is 360 minus 315, which is 45 degrees. Alright, so that's pretty simple right there. So as long as you pay attention to these rules right here, you should be good. Alright, that's it for today, and I'll talk to you guys later. Bye.